what I want to do in this video is make clear the distinction between an iterative, or I should say iterative, I always pronounce it wrong, an iterative function definition and a recursive function definition. And a recursive definition. We'll do it really by just kind of understanding where the iteration is happening over here and where the recursion is happening here on the right. So when we start off, we see that product is set to be equal to 1. And then we enter our for loop. And the for loop really is really the meat of this iterative function definition. And to understanding what's happening in the for loop, let me make a little table here. So I'm going to make a table for the value of our variable I, and I'll also figure out what the value of product times I plus 1, because every iteration through this for loop, we're going to evaluate this business right over here. And then I'm going to make a column for the new value of our product. The new value of our product. So let me underline these things. And then we have the new value of our product. So we learned in many videos ago that in Python, when we say for I in range, this range part right over here, returns a list. And it returns a list of the number of elements that we pass into it right over here. So if we assume, and I should have said this from the get-go, let's assume that we're calling, just to make something specific, let's say that this is the result of a call of factorial of 3. So the argument that we pass to factorial is 3. So the variable number will refer to 3. So when you call range of number, it will literally return a list 0, 1, 2. So 3 elements starting at 0. The last element is 3 minus 1. It is 2. And so each loop through this for loop, I is going to be assigned to each successive element in this list. So on the first time through this for loop, I is going to be assigned to 0. So, or I is going to refer to 0. And then product times I plus 1. Well, in this first loop, product up here, before we even entered the loop, product was defined to be 1. So product is going to be 1. And it's 1 times 1. I don't want to do it in that color. I'll just do it in the magenta. I'll do it in the magenta. 1 times I, which is 0. 1 times 0 plus 1. Plus 1. And then our new value of product is essentially this evaluated. We have it right here. Product is equal to all of this business. And so our new value is 1 times 0 plus 1. Well, that's just 1 times 1, and that's just going to be 1. And that's all we had inside the for loop clause, because that's the only stuff that was indented within this for loop. And so then we go back up. And we're going to iterate through the next iteration of our loop, I guess you could say. And now I is going to be assigned to 1. So now I is going to be 1. This expression over here, we're going to take our old product. So product is still 1. So product is 1. And it's going to be times I, which is now 1, plus 1. 1 plus 1. And what's this going to be equal to? Well, if you evaluate all of this, you get 1 times 2. So now the new value for product is 2 after our second iteration through the loop, our second pass through the loop. And now it will go back to the beginning of the for loop, and I will be assigned to the next element in the list. It'll now be assigned to 2. So I is now 2. This thing over here, we're going to take, it's going to be product. Well, product is now 2. So it's going to be 2 times I. Well, I is now 2 plus 1. Plus 1. And so what does this see? This is 2 times 3, or 6. Or 6. And then it'll go and it'll say, OK, can we assign I to any more elements in this? No, we've run out of elements. So now we break out of the for loop, and we just return the product. Or the variable product, it's what it's referring to. And that's what I should really say. Where we should return the value that product is referring to. And that value is 6. So when you call factorial 3, it will return 6. So if you were to say factorial, of 3 plus factorial of 3, factorial of 3, and you were to evaluate this expression would evaluate to 6, and this expression over here would evaluate to 6, because that's what the function will return. And then you would add those up, and they would evaluate to 12. So this is why we call it iterative. We kept iterating through the same set of instructions. Now let's compare the recursive definition. And this one's a little bit more fun in a lot of ways. So once again, we're going to call factorial of 3. Factorial of 3. So 3 is our argument. That's the value that number will refer to, it'll take on. And it says if number is less than or equal to 1. Well, 3 is not less than or equal to 1. So we're not going to do this part over here. We're going to do the else clause. So we're going to return number. So we're going to want to return number times factorial of all of this. So this is going to evaluate to number, which is 3. That's the argument we passed, times factorial of number minus 1. Well, number minus 1 is going to evaluate to 2. 3 minus 1 is 2. So times factorial of 2. Well, that's just another function called a factorial. So we go back, okay, factorial, but now the argument is 2. So number is 2. We go here. If number is less than or equal to 1, do this. Well, the number isn't less than or equal to 1. It's 2. So now we do else. So what we now want to return is the number times the factorial of number minus 1. Well, in this situation, the number is now 2. And we're going to want to multiply that times the factorial of 2 minus 1. Well, 2 minus 1 is just 1. Times the factorial of 1. Well, we've just made another function call. So the interpreter has to kind of remember that we've made this whole series of functions calls and has to keep digging deeper and deeper and deeper. So now we've called factorial of 1. Factorial of 1. 1 is the argument. Number is referring to 1. If number is less than or equal to 1. Number is less than or equal to 1 now. This is why we call it a base case. We're kind of going down to it. So if the number is less than or equal to 1, return 1. So in this situation, when we call factorial of 1, it literally returns 1. And so we now know that factorial of 2, evaluates to 2 times 1. So this evaluates to 2. And now we know that factorial of 3 evaluates to 3 times 2, which evaluates to 6. So very different ways of thinking about it, but getting you the exact same result. Once again, if you take factorial of 3 plus factorial of 3, it doesn't matter which way we implement it, we'll get 6 plus 6 or 12.